Okay, so we're just going to go through the probability test that you had the other day. With regards each of the four questions, I have given you an average mark. All four were marked out of 10. The average percentage of the whole class was 72%. So we have 10 marks for part A, 10 for part B, 10 for part C, and 10 for part D. So the first question was around with regards arrangements. It was to do with a team where 15 players could be picked from a panel of 20. So for part one, one player must play, so that player is definitely in. So what you would have had left over was 19 players, and you could only pick 14 positions. So you get your calculator, 19 choose 14, it's 11,628. Okay, so that's part A. The second part, part 2, says that two players cannot play together. So we look at all the possible arrangements, minus the arrangements where if those two players were to play together, it would be 18 choose 13, and all your arrangements is 20 choose 15 minus 18 choose 13, and that was 8,568. So part B then, conditional probability. What is the probability of B occurring if A occurs? So what you need to do, the formula you have for conditional probability is the probability of A intersection B all over the probability of B. So with this question, you need to have a good understanding of from your junior cert Venn diagrams. So P of A and P of B. Just get another marker. Pink with it. Okay, so remember that the probability of A is everything in A, and the probability of B is everything in B, where the intersection part, okay, is in both A and B. So you are given probability of A, the probability of B, and the probability of A union B. To find the probability of A intersection B, it is P of A plus P of B. Okay, and then you take away the probability of A union B. That's how you will find the intersection. So P of A was 0.35, so 0.35 plus 0.46 minus 0.61. So your P A intersection B is 0.2. And then we sub it back into our first formula up here, which is 0.2 all over 0.46, which is your P of B, which simplifies to give 10 over 23. So as I was saying, quite well answered. That was on average 7.9 out of 10. Okay, so what let a lot of people down was Bernoulli's trials. So how did you know that this particular question was a Bernoulli's trial? The Bernoulli's trial has specific characteristics. The characteristics that you can clearly see is that there's two outcomes. He either scores penalty or he doesn't score penalty. There's a fixed number of trials, so he takes 12 penalties. Okay, and the events are independent of each other. What that means is, as the probability was 3/5 for the first penalty, the probability is 3/5 for the second penalty as well. So I'm just going to read out the question. So the question says, a player has 3/5 of a chance of scoring a penalty in a match. During this season, he takes 12 penalties. Find the probability that, for part I, he misses the first two and scores the rest. Give your answer to four significant figures. And part 2, he scores his 6th penalty on the last attempt. So for part 1, the probability is that he misses his first and his second, and then he scores next 10. So the probability of him missing was 0. If he scored, it was 0.6. If he missed, he failed, it's 0.4. So it's 0.4 squared because it's 2 events, and, which means we multiply, 0.6 to the power of 10 on your calculator. That is 0.000966745. It says to 4 significant figures, so 1, 2, 3, 4, and we're going to round it up, so it's 0.0009675. Okay. Part 2, reading the question, it says that he has, he scores his 6th penalty on his last attempt. What that means is that he scored on his first 9 attempts. He scores 5 in first 9. Okay, so he scores his 5 attempts in his first 9, and then he scores his 10th. So we're going to have to use Bernoulli's formula to find the probability of scoring 5 in his first 9. So we're just going to go up here. You can see that the formula is n CR p to the power of r by q to the power of n minus r. What do each of these letters mean? N is a total number of trials. Okay, sorry, it's 5 in his first 11. He took 12 penalties, not 10. Apologies for that. So he n is the number of trials, so in this case n will equal 11. The success we looked at earlier on, so his success was 0.6, his failure is 0.4, the two of them add up to 1, that's why it's Bernoulli's, and or is going to be 5. Okay, so or is it how many of those 11 was he successful in? So we sub that into our all the values into our formula. So it's going to be 11 choose 5 by our success 0.6 to the power of 5, our failure 0.4 to the power of 6, he's failed on 6. That accounts for the first 11, and then he scores his 12th. So we multiply everything there by one more success, and the success was 0.6, and that as a solution is 0.0 to 3 decimal places, 0.088. Okay, so that's Bernoulli's trial. There's a lot there. We had an average of 3 out of 10, so it is something that you will need to look over. I will put a worksheet and another video on Bernoulli's up before your exam. Okay, expected value, I'm just going to move over. Okay, expected value, an average score of 9.3, quite well answered. Okay, we had a wheel, 4 different values. You could win €0, 2, 6 and 12. So spin the wheel. It costs €6 to enter, and was you could win 12, you could win 6. What you need to do is, for an expected value, it's the amount of you're going to win multiplied by the probability. So for the first region, it's 0 multiplied by a quarter. It's 0. This region here, it's €2 multiplied by a quarter. So the expected value there is 0.5. The expected value on a 6 will be 1.5, and the expected value on the last quarter is 3. You add them together, you see your expected value is €5. €5 is less than the €6 they expected you to pay to play the game, so it's not a fair game, so you wouldn't recommend it. Okay, so good work everybody on the test, and next week I will have a video up of a couple of topics that will be coming up on your summer test, and I'll go into them in a bit more detail. Okay.